I'm recording this. Okay, I just started the recording, so you're gonna have me at a little bit of a disadvantage there. Maybe I'll fill in the beginning when I get home. Okay, turned on the recording now. Okay, so how are you doing, Marcy? Type in. Still awake? Good. Okay, good. I got a good there. Okay, so this number that we just created here is called the sum of the squares. That's the name of that function. Okay, commonly used function is going to come up later on in the semester as well.
You're talking about the 512.
Yeah, that 512 is the sum of the squares. It's really the real. The real description is the sum of the squares is the differences for each individual value in the mean, right? So it's the sum of the squares. That gives us a handle on how big the variance is, right? How big the variability is in these numbers. The bigger the differences are, the bigger the squares of the differences are, the bigger the sum of the squares is going to be. So that's a handle on how spread out these numbers are from the mean. Okay, so now the only problem with this is that these numbers are in 80, 90, and so on and so forth. That some of the squares is like an order of magnitude bigger because we squared it. We took all these values and squared it. Let's bring this back into, well, first of all, before we do that, let's divide this by the number of items that we have here so we can see what the kind of the average difference is. Okay, except that for reasons that will become probably not that clear to you even later, we're not going to divide by the sample size 10. We're going to divide by the sample size minus 1, n minus 1. Okay, so I'm going to take that 512, right? I'm going to go into this box over here, equals 512 divided by 9. Okay, and that's kind of our average sum of squares, mean sum of squares. Well, that's called degrees of freedom. I'm trying to avoid like talking about that too much right now because it's kind of a complicated concept. But to summarize it, what the degrees of freedom tells us is, for instance, if you have one number, how many degrees of freedom do you have in picking out a number? You only have one number. You have no degrees of freedom. There's no freedom at all. If you have two numbers, how many degrees of freedom in picking out a number do you have? Well, you have 1 degree of freedom. You can pick out one or the other number. If you have 50 numbers, you have 49 degrees of freedom, right? So that's kind of a concept that we use in statistics. And as it turns out, by using n minus 1 instead of n, the math works out better in the long run. Okay, we don't have to worry about where we're in an introductory course. We don't have to really worry about the real physics and probability of this whole thing. But for various reasons, we divide the sum of squares. We divide x. What is that now? That's really x minus x bar, right, squared, divided by n minus 1. Okay, and that gave us that 56.94. Now, let's give that a name. That's a name that gives us the average differences, average sum of squares differences for each individual value. And let's give that a name. We're going to call that the variance. So from now on, that's how we're going to calculate something called the variance. Now, again, this number 56 is much larger than the actual differences themselves because we squared it at the beginning of this whole process. So now we're going to take this variance that we just calculated, and we're going to find the square root of that variance, right? We're going to bring it back down into the range of the real numbers again. We're going to work backwards so that the size of these numbers makes some sense. So I'm going to do that by typing into this box an equal sign. I'm going to use a function built into SPSS called square root, SQRT parentheses, and I'm going to tell it I want to find the square root of that number, x minus x bar squared divided by n minus 1, the variance. I'm going to find the square root of the variance, which is in C14. I'm going to hit enter, and that number now I'm going to call the standard deviation. Okay, that's probably the most important calculation that we're going to do in statistics this semester. The standard deviation tells us an enormous amount about the variability of the values in this list of numbers, in this sample. Okay, that's how we calculate the standard deviation. You will never do this again, ever, right? We did this so that you would understand how you derive the standard deviation and the variance. In real life, how would I do this? Equals standard deviation, STDEV, and I take the whole group of numbers, hit enter, and I get the same number I did by going through that whole calculation, right? As a function built into SPSS that gives me the standard deviation equals STDEV parentheses. They're different functions. I wouldn't worry about it right now. You can just use STDEV. Okay, you're going to find a number of specialty formulas in Excel that a lot of times within what we're doing here, you're not going to be using. I'm sorry. How does it know to do when it gets to the step of n minus 1? How does it know to do 9 instead of 10? You mean the actual function itself? Yeah, like yeah, it's actually it's all built into it. It's actually doing this entire process. Like it's doing a count. It's actually, for instance, if I have a function here called count, parentheses, and I can just tell that I want to count from this point to this point, it'll tell me how many items there are there. Just tell me there's 10 items. Well, so that's actually built into the standard deviation calculation. So all of that. The lecture that we did, he said that there's 2 standard deviations. One is the n, one is n minus 1. Oh, I got you. Okay, we're going to be using n minus 1 for the most part. Always that. Yeah. Yeah, one for a sample, one for a population, most likely is the way I think is the way he was probably describing it. Okay, so if you look at what we just did here, the version that's n minus 1 is the version that Excel is using, right? Because that's where we came up with the same numbers. Okay, everybody comfortable with that? No, you're not comfortable with that. Oh, it's still not working. Look, hang on a second. I'll tell you what. We're going to take a break in a little while, and we'll take a look at it. Is it your version of Excel is not working at all, or are you having a problem with the work? I'll work with you. Okay, so now I'm gonna move away from this. Okay, this is our exercise. In real life, from now on, we're going to be using actual built-in functions, but this is how we derive variance standard deviation from a sample. Okay, so now I'm going to open up the next file we have.